Hello everyone. In this video, we're going to continue talking about lesson 9, which is about hypothesis tests and confidence intervals for one mean mu. So in the last video, we talked about a confidence interval for means, and now we're going to talk about a hypothesis test for one mean. So you'll notice that throughout this video, this material is going to be very similar to that of lesson 8, because that was lesson 8 was about hypothesis tests for P, and you'll see that hypothesis tests don't vary much from different parameters. Okay, so hopefully it will make a lot of sense. Okay, I'll give you the steps of a hypothesis. Again, the 8 steps that I'm looking for, an example, and then I'll give you your turn to test your skills. I'm not going to go through all the fluff that I did in lesson 8 to talk about what a hypothesis test is. Okay, and so if you're rusty and haven't thought about it for a few days, you may want to go back to lesson 8, okay, and just browse through those slides to get yourself reacclimated. So the first step in a hypothesis test is going to be the same as the first step in a confidence interval, and that is to describe your parameter of interest. Now, in lessons 7 and 8, I always had this step here, but it was kind of pedantic because the only parameter that you were ever interested in was P, okay, some proportion. And it's important to know what proportion you're interested in, and so it was still valuable, but now we get to where I think this step is really important, okay? Because in something like the final, you're going to notice, or you now have the option of choosing whether or not the question is about a mean or about a proportion. And so this first step is going to help you think about whether it's a mean or a proportion, and specifically what mean or proportion you're working with. So that's the first step and why I think it's important. The second step is to identify the null and alternative hypotheses. And so this is going to be very similar to what you saw in the hypothesis test for P. The null hypothesis is always a statement of agreement. Okay? Before, in lesson 8, we said it was P equals some number. Okay? Now it's mu equals some number. So the only thing that's changed is it's now mu equals whatever. That number, mu naught, will always be given in the problem somehow or some way, right? And the alternative hypothesis is that we have one of 3 choices. Okay, so the null hypothesis is easy. It's always the same thing, always equal. In the alternative hypothesis, you have 3 choices: less than, greater than, or not equal to. As a small reminder, you'll know, hopefully, by the problem which alternative hypothesis you're going to use. When the problem states a direction, whether it's less than or greater than, I think something has increased or something has decreased, then you want to choose the inequality that goes with that direction, of course. So if it's less than, and I think something has decreased, then you're going to choose less than. Okay. Same with increased. When the problem doesn't imply a direction, I think something has changed, or I think something is different, but I don't say which way it's changed or which way it's different, then you choose not equal to. Okay, so those are the hypotheses. Step 3 is the level of significance, which is given in the problem. Okay, so that's pretty self-explanatory. Step 4 are the assumptions. And these assumptions are going to be the same assumptions that we talked about when going over a confidence interval for mu in the last video. So those are that the data is taken randomly and that the population distribution is approximately normal. Hopefully it says whether or not the data was taken randomly in the problem. And nice for you is that usually we can't test if the distribution if the population distribution is approximately normal, and so we have to sort of believe it's true and go forward in our problem. Okay, so those were the first 4 steps. Now we get to the second 4. In step 5, we make the critical value, or what I call the test statistic. Okay, and that is very similar to the critical value / test statistic that we did for a hypothesis test for P. Okay, it's the point estimate, x bar, minus that hypothesized value mu naught divided by the standard error of the point estimate. Okay, and so you'll notice that these symbols and sets of symbols are very similar to what we saw in the confidence interval type stuff, and that is for a reason. Okay, and you'll also notice that we substituted in S here for sigma. And so when we do that, just like in confidence interval land, the distribution of this test statistic is now a t distribution, not a normal distribution. So it follows the t and not the normal. And so that makes a difference when we talk about the p-value in step 6, because we are now going to have to use the t and not the normal to find our p-value. Okay? And so the p-value changes based on the alternative hypothesis, but you don't really need to worry about this step because StatCrunch is going to make or calculate that p-value for you. Okay? It will always calculate it for you. In fact, the way I'll show you how to do these problems, you won't even need to use the t calculator. And then in step 7, and really this is step 7 and step 8, are the decision and the conclusion. So the decision is whether or not you rejected the null hypothesis, and you don't put any sort of context into that problem. It's a simple statement of is the p-value less than or greater than alpha, and then what decision do you make based on that? Okay, and sorry, the conclusion, I'm sorry. The conclusion is a restatement of the decision in terms of the problem. And it's often in terms of the alternative hypothesis and not the null hypothesis. So let's do an example. Okay, and I'll show you how to use StatCrunch during this example. So here, Bon Air Elementary School has 1,000 students. The principal thinks that the average IQ of students at Bon Air is at least 110. To prove her point, she administers an IQ test to 20 randomly selected students. Among the sample students, they had an average IQ of 116 with a standard deviation of 110. Sorry, 10, not 110. Based on these results, should the principal accept or reject her original hypotheses, assume a level of significance is 0.01, and assume that the population of, not engines, that's a typo, of IQs are normally distributed. Okay, so here we go. The first step is, of course, the parameter of interest. I'll call that POI, right? It's mu. We're looking at a mean, and I'm looking at the average IQ score for all students at Bon Air Elementary School. Okay, the hypotheses are this. Okay, so the sort of point of contention is around 110. Okay, the principal thinks that that the average IQ of a student is at least 110. So hence assuming greater than 110. Right? You could put equal to there, but we don't really go over that. We only have 3 choices: less than, greater than, or not equal to. This, of course, falls into the greater than camp. Okay, so the alternative hypothesis comes from the principal's statement of at least 110. Okay, and then the null hypothesis is always a statement of agreement, and the number on the right-hand side of that hypothesis always needs to be the same. So, of course, the null hypothesis is that mu really is 110. So, great. First step, second step, both done. The third step is the level of significance. In the problem, it says to assume a level of significance of 0.01. So, good so far. Assumptions were the data taken randomly? And yes, they were. Okay. To prove a point, she administers an IQ test to 20 randomly selected students. randomly selected, and so taken randomly. Great. And is the population distribution normally distributed? Here, it actually says, assume that test scores in the population are normally distributed. Okay, if you just take out the engine part. So we have both of those assumptions are checked. Great. So then let's calculate the t-score for that critical value. It's the point estimate, 116, minus the hypothesized value of 110, divided by 10 over the square root of 20. And so my t-score is 2.683. Great. Okay. And then after I do the calculations, which I'll show you in just a second, I get that the p-value is 0.007. So since the p-value is less than the alpha value, since p is less than alpha, we reject the null hypothesis. And I say, at the 1% significance level, there is enough evidence to suggest that the average IQ score of students at Bon Air Elementary is larger than 110. Okay, so now, how did I get the test statistic? Well, that's pretty self-explanatory. How did I get the p-value? So on and so forth. So, okay. And of course, we could use the calculator along with the value that I gave and the t calculator to do that. Okay, and you can if you wish, but I'm going to offer you a different and you'll think better way. Okay, so we're going to go down to t-stats. Okay, since we're working with a t, we're going to t-stats, one sample with summary. Okay, we only have summary information here. Okay, and so it gives us a number of options. What was the sample mean? The sample mean was 116. The sample standard deviation was 10, and the sample size was 20. Okay, here's our hypothesis test. Okay, we can actually do a confidence interval. So really, you can actually do a confidence interval for our last set of slides, okay, if you want to. But we're focusing on hypothesis tests here, and the null hypothesized value is 110, and our alternative hypothesis is greater than. Okay, so it asks you a number of questions down here you don't need to think about. You hit compute, right, and it comes out with a table here. Okay, that doesn't get any larger. So here is the table. Check to see if your hypotheses match what you put before. The answer should hopefully be yes. Okay, if you come down here, you'll see the sample mean. Great. It calculates the standard error. Great. Here's the degrees of freedom, the sample size -1. It creates, or it finds the t statistic for you, 2.68. Okay, 2.683, which we found here. And then it gives you the p-value. Okay, there's no need to think about anything there. It just gives you the p-value, and you can go on your merry way. So hopefully, to go through these steps. Okay, so here's a reading assignment, page 408 to 416. Will give you a little bit more in-depth reading on hypothesis tests for mu. Okay, and then here is a your turn that you can do to try to get a handle on a problem doing it yourself. Okay, and so that's the end of this video. Actually, one thing that I want to show you is when I actually give you data. Okay, so very quickly. Going to exit out of StatCrunch. Okay, so when I actually have data, okay, so suppose I didn't give you that the mean IQ score was 116 with a standard deviation of 10. What if I actually gave you those 20 IQ scores? And so when I do that, I want you to put them in one column. So maybe it's 110, 112, 88, 96, 115, 105, 108. Okay, so suppose that I here have 10 scores, 10 IQ scores, and I want to perform a hypothesis test or do a confidence interval based on this stuff. So again, I would go to, just like we did before, stat, t-stats, and we're again working with one sample, but instead of going to with summary statistics, with data. Okay, so it's going to ask you which column is your data in, and I'm going to say variable 1. So I clicked and I pulled over, okay, variable 1. And then again, you go down here and you tell the hypotheses what you want. It gives you a bunch more options, okay, which means you can do more with real data than you could with something else, okay? But we won't get into these. All right, lots of options down here, but you click compute and it will give you the same information that you got before here. Of course, this is different because I just made these up. Okay, but it still gives you a t-statistic, it still gives you a p-value, the degrees of freedom, standard error, sample mean, and you go forward with a test like that. Okay, the same thing would occur with a confidence interval. All right, so that's where I end this video. I'll see you next time.